Our video today is going to be on triangles and identifying different types of them as you move through the geometry section. So let's refresh a little bit. A polygon, an object that has sides with vertices and angles. And we'll get through all of them as you go through the geometry section with this part. So here's a polygon. Again, they have to have sides, they have to have angles in order for it to be a polygon. A circle is not a polygon. So specifically in this part, we're going to talk about triangles. And the word tri means three. So angle, we've defined that as a part of two rays coming together or going out from a vertex. So a triangle is a three-sided polygon. In a triangle, if we add up all the angles in there, it would equal 180 degrees, which is also known as a straight line. So some triangle classifications that you're going to be asked to do, and that is by sides and by angles. And we're going to talk about each one of those separately. So if we talk about sides first, the first one we come across is what's called a scalene triangle. In a scalene triangle, no sides of the triangle are equal or congruent. So here's some examples of a scalene triangle. You notice that all sides are different in length, and so they will not have any commonality between them at all. For an isosceles triangle, iso meaning two, so a isosceles triangle, which is kind of a hard one to say, so you might want to practice that a few times, is a triangle that has two sides that are congruent or equal. Some examples of these, you can see that this side is congruent or the same as this side, and this side, along with this side and this side of these triangles. An equilateral triangle, the word equa prefix comes from the word equal, so meaning all sides of the triangle are equal or are congruent. You also might hear a regular polygon, regular triangle. That would also be an equilateral triangle or a regular polygon, meaning all sides are equal as well. So as you can see in this, you have three sides that are the same length. And sometimes it's kind of hard to tell. Sometimes you have to get a ruler out. But for the most part, it's pretty easy to tell whether it's an equilateral triangle or not. Other way that you're going to be asked to do this is by angles. So some of these angles are going to sound similar to the angle section that we've done. So the first one is an acute triangle. These are all three angles must be less than 90 degrees to be an acute. And again, remember the angles, if we add them all up, will be equal to 180 degrees. So here's an example of some acute triangles. As you look at some of the angles here, they are less than 90 degrees. And if we add them all up, they should equal 180 degrees. So a right triangle, one angle must equal 90 degrees or make a corner. And you'll see that symbol for a right angle as you go into the triangles. The other two angles will be an acute angle. So again, if we add those three up, you get 180 degrees. So here's an example of a right triangle. Notice when you see this, you have the corner here being a right triangle, and that will be the symbol that they'll use in there. They won't necessarily give you the degrees of 90 degrees, but they will give you the right or the corner symbol as you can see it as a right triangle. Other one is obtuse. One angle in the triangle is larger than 90 degrees. So the other two angles have to be an acute because you already have a large angle. And if we add them up again, it has to equal 180 degrees. So here are some examples of an acute triangle. You can see that these are larger than 90, even though it may sometimes be a little bit fuzzy on that, but most of the time they'll be pretty straightforward. The other thing about a triangle is you can always find the longest side by looking for the largest angle in the triangle, and the longest side will be always opposite of that angle. So it's a good way of kind of referencing where your longest side of the triangle will be in different questions that you're getting. So what you can do now is you can basically put these two together and say, well, we can classify it both by sides and by angles. And it depends on the person that is instructing you, whether they want sides first, angles first, or vice versa. So you could have an equilateral acute or an acute equilateral triangle, meaning you have all the angles are less than 90, all sides are equal. You can have an obtuse scalene, where you have a one angle that's larger than 90 and none of the sides are the same. And you can even have a right isosceles, meaning you have one triangle or one angle is 90 degrees and there's two sides that are equal to each other. Last thing is, and this is just a little extra information, is when they want you to find if you can create a triangle by the given sides, the theorem or the fact of this is it's the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if you look at the examples that I've given you here, if we take x plus y, it has to be greater than z. If x plus z is greater than y, that works. If it's y plus z is greater than x, it also works. So it's an interesting theorem to work through to figure out that you can create a triangle given the sides of what they give you in the problem. So if we look at one and say, well, if we try this, I've given you a triangle that has sides 8, 12, and 9. So if you go through the checklist over here, you can see that if I add 8 plus 9, that is 17. It is greater than, so that works. If I add 8 plus 12, again, that works because it's greater than 9. And 9 plus 12 is greater than 8. So that checks out. So this would be a triangle that you can create for an example of that. So hopefully this works with this. One of the things that you want to do is make drawings. If they just give you the numbers or give you the angles, try and create a drawing for that to help understand the sides, the angles that they're given for you. And make sure that you use your notes and ask any questions if you need any.